In question 1, A intersection B means that whatever is inside both A and B, so these 4 numbers, let's write them down, 2, 4, 6, 12. You can use curly brackets. You won't be penalized if you want. Now for part B, B dash means whatever is outside B, so we're talking about these 3 numbers and these 5 numbers. So let's write them down. I'll write them down in order. That's not compulsory. So 5, 7, 8, 9, 10, 11, 13, and 14. For part C, it says find the probability that the number is in set A but not in set B. Let's first find A intersection B dash. This is the number of elements in A but not in B. So the numbers in A but not B are these 3 numbers. So this is 8, 10, and 14. So I've got 3 numbers. I don't need to write them. I have 3 numbers out of a total of 14 numbers. So the probability is 3 out of 14. In question 2, I'll start by converting the 15 hours into seconds. First, I'll do 15 times 60 to convert them into minutes, and then times 60 again. So this will give me 54,000 seconds. And then I'll just use proportion. I've got toys and I've got seconds. I know 5 toys need 12 seconds, so X toys will need 54,000 seconds. I'll cross multiply, so X is 5 times 54,000 over 12. Let the calculator do the job. X will be 22,500 toys, and then the probability of getting a faulty one is 0.002. So to find an estimate for the faulty ones, I'll just do 22,500 times 0.002, and this will give me 45 faulty toys. I'll start question 3 by making a small table of X and Y values. I will use for X the -2, the 3 and something in between. 0 is an easy number, and then I'll plug these X values into the equation to calculate the Y values. These come out to be 15, 7, and -5. So these are 3 pairs of coordinates which I will plot on the graph. Finally, I will join these 3 points with a straight line. Let me zoom out and draw the line. So that's how the final answer looks like. For question 4, I am being told that the median is 9. Now I've got 6 numbers. When I add the 2 middle ones and divide by 2, I should get a 9. So let's start from here. So X plus 10 over 2 is equal to 9. X plus 10 is equal to 18. X is equal to 8. Then I'll use the fact that the mean is 11. So if I add all 6 numbers and divide by 6, I will get 11. Let's use this. So 4 plus 7 plus X, which is 8, plus 10 plus 2Y's divided by 6 is equal to 11. So the numerator is 29 plus 2Y gives me 11 times 6, which is 66. So 2Y is equal to 66 minus 29 is 37. Y comes out to be 18.5. So let's write the answers, 8 and 18.5. For part A, I have a power of -3, so that's 3 extra zeros at the front. It's 0.0057. Part B, I've got 5 zeros after the 8, so the answer is 8 times 10 to the 5. And then part C, now since it doesn't say without using a calculator or show while you're working, you can just put these on the calculator and get the answer. Now, as an ordinary number, the answer is 455 with 4 zeros. As standard form, this is 4.55 times 10 to the power of 6. Both of these are equally accepted. For question 6, recall that time is equal to distance over speed. In our case, I've got a distance of 100 kilometers divided by a speed of 28,440 kilometers per hour. If you do this on the calculator, you will get 3.516 ... times 10 to the -3, and these are hours. We need the answer to the nearest second, so I will multiply by 60 to convert to minutes, and then by another 60 to convert to seconds. So 3.516 times 10 to the -3 times 60 will give me 12.6 and so on. So the answer is 13 seconds, correct to the nearest seconds as required. I'll start part A by expanding the brackets. So I've got 20 minus 5x equals 7 minus 3x. Let's collect all the x's on the right hand side. So I've got 2x. Let's collect the numbers on the left, 13. So x is 13 over 2. For part B, the common factor is 8m squared g to the power of 3, and then I'm left with 2m plus 3g squared inside the bracket. For part C, I'll start by factorizing. So I've got y minus 8 in the first bracket, y plus 6 in the second one. And if I set this equal to 0, so if I have y minus 8, y plus 6 equals to 0, I will get y is equal to 8 or y is equal to minus 6. So 8 minus 6 are the two answers. For question 8, note that in this 10-sided polygon, the 9 angles given are interior angles. X is an exterior. The corresponding interior, this one, is 360 minus x. Next, I'll use the following fact. The sum of interior angles of any polygon is n minus 2 times 180. In our case, the sum of the 10-sided polygon is 10 minus 2 times 180, which comes out to be 1440. So if I add all the interiors, I should get this number. So let's set up an equation. 125 plus 134 plus 168 plus 150 plus 148 plus 150 plus 168 plus 134 plus 125 plus 360 minus x is equal to 1440. So the left hand side simplifies to 1662 minus x equals 1440. So let's take x to the right. 1662 minus 1440 comes out to be 222, and this is my final answer. For question 9, since I have a reduction by 20%, This means that I'm going from 120 down to 80, so the multiplying factor is 80 over 100, or 0.8 as a decimal. So the normal price times my multiplying factor is equal to the final price. So the normal price is equal to 1080 over 0.80, which comes out as 1350, which is the final answer. For question 10, I'll start by writing number B as the product of prime factors. 16 is not prime. 16 is the same as 2 to the power of 4, and then I've got 3 to the power of 37. Now for part A, to find the highest common factor, I'll need all the common factors to their lowest powers. So 2 is common, lowest power is 1, and then 3 is also common, lowest power is 37, and I'm gonna leave my answer like this. For part B, I need to find the product of A and B. Now, the product of A and B is equal to A, which is 2 times 3 to the 43, times B, which is 2 to the 4 times 3 to the 37. So the 2's will give me 2 to the power of 5. The 3's, if I add the powers, will give me 3 to the power of 80. So this is my final answer. For question 11, I'll start by using the fact that the area is 179.4. Now, at the back of the cover on the formula sheet, I'm given the following formula. A and B are the two parallel sides. H is the height of the trapezium. So let's use this formula. 179.4 is equal to 1 over 2, 17.6 plus 8.4 times H. So 179.4 is equal to 13H. So H comes out to be 13.8. Now I'm being told that this trapezium is isosceles because it has one line of symmetry. Here it is. Now if I draw perpendiculars from B and C to form right angle triangles, this is what I get. The base of each of these triangles is x, and to find x, I'll just do 17.6 minus 8.4 over 2, which comes out to be 4.6. So let's consider the left triangle, this one, and let's try and find angle theta here. So let's extract this triangle. So to find theta, I'll just do tan theta is equal to opposite, which is 4.6 over 13.8. So theta is the inverse tan of this fraction, which comes out to be 18.4. So to find angle ABC, I will need to find this angle here, which is 18.4 plus 90. So let's write this down, 18.4 plus 90, which gives me 108.4 degrees, which is my final answer. For question 12, to solve the simultaneous equations, I can use either elimination or substitution. In this case, I find elimination easier. To do so, I'll multiply the first one by 5, the second one by 2, so the y's are the same with opposite sign and they cancel out. So for the first one, I get 35x minus 10y is equal to 170. And for the second one, I get 6x plus 10y is equal to minus 6, and when I add these two together, the y's cancel out and I'm left with 41x equals 164. So x comes out to be 4. Now I will substitute this one into any of the equations. Let's take for example the second one. So I get 3 times 4 plus 5y is equal to minus 3. 12 plus 5y is minus 3. 5y is equal to minus 15. So y is equal to minus 3. So my final answers are 4 and minus 3. For question 13, I've got an increase of x% per year. This means that my multiplying factor is equal to 100 plus x over 100. Now, if you want, you can split this into 2 and get 1 plus x over 100. Both are accepted. Now, the theory says that the original value, 8,000, times my multiplying factor to the power of 6, which is the number of years, will give me my final amount. So let's start by getting rid of the 8,000 using division. So 100 plus x over 100 to the power of 6 will be equal to 1.109705. So 100 plus x over 100 will be the 6th root of this number, which will give me 1.0175. So let's try and solve this equation now. Let's cross multiply. 100 plus x is equal to 101.75. So x is equal to 101.75 minus 100 is 1.75, and this is my final answer. For question 14, if I put the first sentence into mathematical symbols, then it looks like this. This reads proportional to. Now I can convert this into an equation by saying f equals k over v squared, where k is the constant of proportionality. I can find this by substituting these values in. So 6.5 is equal to k over 4 squared. So k comes out to be 104. So for my final answer, I'll write the formula f equals to 104 over v squared. Make sure you put the f equals at the beginning. For question 15, I've got the two spinner situation. I need to complete the tree diagram. Now spinner A has 2 reds, so 2 over 5 for red, so 3 over 5 for green. Spinner B has 4 reds, so 4 over 5 for red, 1 over 5 for green. Same for the branch below. For part B, I need the probability at least 1 green. Now, at least 1 green, there are 2 ways to do that. I can either find all the combinations that give at least 1 green. So I've got these rows, I've got these rows, and this one, and add these outcomes together. Or I'll find the only one that doesn't satisfy this condition, the red one, and then do 100%, which is 1 minus this probability. So let's proceed with the second method. So probability, both are red, is equal to 2 over 5 times 4 over 5, which gives me 8 over 25. So probability at least 1 green is equal to 1 minus 8 over 25, which gives me 17 over 25, and that's the final answer. For question 16 part A, I need to find this angle here. Note that these two are opposite angles in a cyclic quadrilateral and they add up to 180. So I've got 180 minus 58, which is 122. And the reason is opposite angles in a cyclic quadrilateral add up to 180 degrees. For part B, I need to find the reflex angle MOP. So I need to find this one. Note that this one is twice MLP because angle at the center is twice the angle at the circumference. So 122 times 2 is my calculation. The answer comes out to be 244. Note that you can find this one, the obtuse angle. This is twice 58, and then 360 minus this one will give you the required angle. In question 17, some people find it easier to convert the 5 kilograms into 5,000 grams. Now this is given correct to the nearest 50 grams. That means I'll take that quantity 50 divided by 2, 25, and add or subtract 25 from 5,000. So M is between 4,975 grams and 5,025 grams. If I convert this back into kilograms, that's 4.975 kilograms, 5.025 kilograms. Now the volume is given by this number to 3 significant figures. That's easier than the mass now. So the upper bound is 1.845 times 10 to the minus 3. These are meter cubed. The lower bound is 1.835 times 10 to the minus 3, again meters cubed. Now to find the density, recall that density is equal to mass over volume, and since I need the upper bound of the density, I will need to divide the upper bound for the mass, which is this one, by the lower bound of the volume, which is this one. So let's write this down. 5.025 over 1.835 times 10 to the minus 3, and the calculator will give me 2,738.4 kilograms per cubic meter. For question 18, I'll need 2 extra columns on my table, one for class width and one for frequency density. Recall that frequency density is equal to the frequency divided by the class width. Now to find the class width, just subtract the upper and lower bounds of every group. So for the first one, 20 minus 10 is 10. Second one is 15, 15, 20, and 10. And then for the frequency density, just divide the frequency by the class width. So we've got 3.5, 3, 5, 2, and 0.8. Now frequency density will be the height of each bar. So if I go to my histogram, I will label as 1, 2, 3, 4, 5, 6. The first bar goes from 10 to 20, has a height of 3.5. Second one goes from 20 to 35 with a height of 3. Third one from 35 to 50 with a height of 5. Next one, 50 to 70, height of 2. And the last one from 70 to 80 with a height of 0.8. And that's how the final histogram looks like. In part B, I'm being asked to work out an estimate for the number of plants with a height of greater than 40. So if I go to my table, height of greater than 40, I've got these 40 and 8 plants and a fraction of the 8 of the 75. Now to find the number in that group, consider that between 40 and 50 there is a range of 10. The whole group goes from 35 to 50, which is 15. So 10/15 is the fraction I'm looking for, times the frequency of that group. This will give me 50 plants. So 50 plus the last two groups will give me 98, and that's my required answer. For question 19, if you take this fraction and put it on the calculator and press the equal sign, it will give you 9 plus 3 root 7. That's the final answer, but the question says without using a calculator, so we need to show every step of the process. Now, remember that this procedure is called rationalizing the denominator. Let's start from the original fraction. I will multiply by a fraction where both top and bottom are the same. Before doing so, I will make a note. This identity is called the difference of two squares. Note that the xy terms cancel out, so applying this identity for the denominator, I'll need to have 3 plus square root of 7. The reason we did that is that in the denominator, when you do the multiplication, you'll get 9, which is 3 squared, minus square root of 7 squared, which is 7, and the 3 root 7 cancels out. In the numerator, I've got 6 times 3 plus root 7. I will not expand just in case something simplifies. So 6, 3 plus square root of 7 over 2. Here is my simplification. So now I can expand and get 9 plus 3 square root of 7, which we know is the correct answer. For question 20, recall that when you have similar shapes, if the scale factor for the length is k, for example, the scale factor for the area is k squared, and the scale factor for the volume is k to the power of 3. I can summarize these in a table like the following. Let's put our information on this table. I know that the area of R is 108, the volume is 135, and for shape S, the area is 300. I need to find the volume of shape S. Now I can use the areas to find the value of k. 108 k squared is equal to 300, so k squared is 300 over 108, which is 25 over 9. K is the square root of 25 over 9, which is 5 over 3. So to find the volume of shape S, we'll just do 135 times 5 over 3 to the power of 3, and this comes out to be 625, which is my final answer. For question 21, I'll start from the multiplication and try and simplify this expression. So 1 over 3x minus 2 times, now let's factorize top and bottom. The top one is the difference of two squares, so it's 3x minus 2, 3x plus 2. The denominator is 3x plus 2 with x minus 5. Now I can cross out the x minus 2 with the x minus 2 and the x plus 2 with the x plus 2. So I'll be left with 1 over x minus 5. So now let's try and do the subtraction. 1 over x minus 5 minus 7 over x minus 1 is equal to, now the lowest common multiple of the denominators is x minus 5, x minus 1. I'll multiply the first fraction by x minus 1, the second one by x minus 5. So I get x minus 1 times 1 is x minus 1 minus, now I'm going to keep the brackets here, 7 times x minus 5. Let's expand the numerator now. X minus 1 minus 7x, and be careful, minus times a minus gives a plus 35. Denominator stays the same, so the numerator now simplifies to 34 minus 6x over x minus 5, x minus 1. Now I need to check for factorization at the top to check for simplification. If I factorize, I get 17 minus 3x, x minus 5, x minus 1. Nothing cancels out, so both of these are acceptable answers. Let's begin question 22 from the equation of line AC. Let's rearrange to extract the gradient and y-intercept. So 2y is equal minus 7x plus 20. So y is minus 7 over 2x plus 10. So we have a gradient of minus 7 over 2. So the line AC looks like this. And since the diagonals of the rhombus are perpendicular, then the diagonal BD should be something like this. We also know that the diagonals intersect at the point M with coordinates 6, minus 11. So now I'll use the following fact. If two lines are perpendicular, then the gradient of the second is minus the reciprocal of the first. So for line BD, the gradient is equal to minus minus becomes a plus, 2 over 7 is the reciprocal, passes through the 0.6 minus 11, so y equals mx plus c is the equation of a straight line. Let's find c. Minus 11 equals 2 over 7 times 6 plus c. So minus 11 minus 12 over 7 equals c. c comes out to be minus 89 over 7. And the question wants the exact coordinates of the point where this line BD intersects the y-axis, so it needs the y-intercept, which I just found. So 0 minus 89 over 7 is my final answer. In question 23, we need to find the values for which the gradient is negative. So when we say gradient for a curve, we are referring to dy in dx. Let's start by finding dy in dx. Now the power in the first term is 3. I'll multiply the coefficient p by 3, so 3p. X, reduce the power by 1, so I get a square minus, and then I have m times x to the power of 1. So m times 1 is m, x to the power of 0. Now x to the power of 0 is 1, so I get 3px squared minus m. And since the gradient is negative, this must be less than 0. So note that I have a quadratic inequality to solve. Now to solve this quadratic inequality, let's first solve the corresponding quadratic equation. So 3px squared is equal to m. So x squared is m over 3p. So x is equal to plus or minus the square root of m over 3p. Now to solve the quadratic inequality, let's consider a quadratic graph like the following one. The two roots are the roots I found before, and because my quadratic inequality says less than 0, I need the region that is below my x-axis, and the region below the x-axis is the region between the two roots. So my solution would be the following. X is between minus square root of m over 3p and positive square root of m over 3p. Now for question 24, I've got an arithmetic sequence that has first term 8 and common difference 7 because I'm adding 7. Now recall that the formula for the sum of the first n terms as given in the formula sheet is the following. Now note this formula works from the first term. So if I want the sum of terms from the 50th to the 100th, so 50th all the way to the 100th, I will use the formula from the first to the 100th, and then I will subtract the sum from the first up to the 49th, and the reason I'm stopping at 49 is because I need the 50th, so I should not subtract the 50th term. So S100 is equal 100 over 2, 2 times 8 plus 100 minus 1 times 7 comes out to be 35,450, and S of 49 is equal to 49 over 2, 2 times 8 plus 49 minus 1 times 7. This comes out to be 8,624, and when I subtract the 2, I will get 26,826, which is my final answer. Note there is an alternative way. This involves finding the 50th term using the formula a plus n minus 1d, and then use a new series that starts from the 50th all the way to the 100th. So it's a series that contains 51 terms. In question 25, g of x is transformed to minus g of x by a single transformation, and this transformation is reflection in the x-axis. For part B, I've got this graph of f of x, and I need to draw the graph of 2 f of x minus 1. Now the 2 represents a stretch along the y-axis by a scale factor of 2. So basically I'm multiplying the y-coordinates by 2, and the x minus 1 translates the graph by 1 unit to the right, so I am adding 1 to the x coordinates. So I'll go to my graph and take some nice points. I'll take the points with integer coordinates. These are the following 7 points, and I'll go on the next page and write the coordinates of this point down. And now I will add 1 to every x coordinate and multiply the y coordinate by 2 to get the following. And now let's go to the graph and plot those red points. Finally, I will join those points using a smooth curve. And that's how the final graph looks like.